All right, good afternoon, everybody. Thanks for joining us again. This is part 3 of our two-wire webinar series. My name is Reid Garner. I am the specification sales manager for the Southeast region. I have on the line with me our technical guru, Mr. Dirk Hessman. He is going to be leading this presentation here. So the first part, which was 3 weeks ago, we talked kind of about basic two-wire concepts, what it is, how it works, some of the products that Hunter offers that are two-wire. Last week, we got into design principles and some basic installation proper practices and some basic troubleshooting. So today is going to be more of a, normally when we do this in person, when there's not a global pandemic going on, this is a very hands-on type situation where we talk about stuff. It's put stuff in your hands. We talk about how to program. But this will be sort of a discussion by Dirk about advanced troubleshooting techniques, and hopefully you'll get some good stuff out of it. So if you have any questions as we go along, feel free to ask them in the question box. I'm going to kind of dip out of here once Dirk gets going, but I'm going to be monitoring the questions. If I can address the question through the chat, I certainly will, but if it's something more of Dirk's purview, then if it's appropriate at the time, I might interject in and ask the question to Dirk at that point. If we don't, if we've moved on, we'll certainly address it at the very end. So don't be shy to ask questions. That's how we learn stuff. So if you got something, be sure to ask it there in the question box. So without further ado, I'm going to turn it over to Dirk, and he is going to go through the presentation, and we will see you on the other side. Thanks, guys. Dirk?
All right. Well, thank you very much, Reid. I couldn't do it without you. Reid, you're wonderful. Like Reid said, my name's Dirk Hessman. I'm the field service manager for the Southeast, and we've pulled some slides together. Hopefully everything will come together and start to make more sense for you in troubleshooting some decoder systems. So without further ado, let's go ahead and get started a little bit in depth. Put questions in the box, or we can always take them later. So here we go. Let's start off with basic troubleshooting tools that you might need in the field. An obvious one is some kind of a voltmeter. It doesn't have to be Fluke. A lot of these might have a brand specific up here, but whatever you're comfortable with, and if there's something that needs to be more specific, I'll kind of let you know. But basically a voltmeter where you can read AC volts, DC volts. Those are the key ones. Shown here is a Fluke, but I've seen everything from $10 ones to $500 ones. If you're comfortable with it and it does the job, it's good to go. Next one is a clamp meter. Now, we have two of them shown here, an X-Tech and an Armada. Now, like I said, either one of them will work, or if you have another one. But the big thing about this, you can't use a typical one. You have to have one that goes down to milliamps. So that's kind of key to be able to go down the line and read where you need to be reading. You're going to need some miscellaneous tools, and these are kind of standard stuff that's in your toolbox. You know, wire cutters, linesman pliers, screwdrivers, taking things apart, putting things back together. So that's kind of sight unseen. Another thing, and keep in mind, I've got every one of these, like when I show up on a job site to help troubleshoot to see what's going on. And this is kind of a key one right here. It's another decoder. It's a known good one with a solenoid attached to it, because that one is great for if you have a dead decoder but you're not sure. You can hook this one in its place and kind of read it and see what it's doing. Another one, there's the test decoder again, but also is a test solenoid. So if you have a decoder that you think might be functioning right, but it's not turning anything on, you can actually just connect the solenoid to it and check it out too. But the one on the left where it has the two alligator clips, you can hook that in line, do some readings, and see where it goes. A tracker. Tracker is very handy, especially if it's an unfamiliar property and you don't know where your wires are going to and from. Because I'm going to be honest with you, you can chase your tail quite a bit if you don't know the path of the wires. A lot of people don't, or they're not supplied with a diagram of the property. So sometimes you have to pull this out and try to figure out where your wires are going to or from. Another thing, if you have a broken wire, you will need a fault finder or an A-frame, as a lot of people call them. Typically, what I showed you in the previous frame, the line, the wire locator, it'll just tell you where wires are. It's non-discriminate. It'll jump into other wires, but this will actually pinpoint where your wire problem is, where it is cut, nicked, damaged. So I recommend getting one of these. Another thing, if you're having problems with lightning hitting your area or that one spot again and again and again, a ground resistance tester. Now you can check your grounds with this, look for noise. This is a handy tool also. And this is something that we have devised. It's an Hunter ICD HP. It's a handheld programmer. From this, you can do diagnostics on the clock, on the 2-wire path, and on the decoder itself. We're going to go through some of the functions of the ICD-HP, but it is a very handy tool to have, and it works on all of our decoders except for the EZ decoder. The EZ decoder is an AC volt system where all of our other ones are DC, and this tool is designed for the DC volt systems. Some of the ICD-HP features are you can do decoder programming. So if you put a decoder out into the field, you can program it while it's on the 2-wire path, or if you're on your bench and you know what number it's going to be, you can go ahead and program it using the red and blue leads that are shown in that box. You can update decoder firmware. Each one of these decoders is actually a mini computer. And as we see a possible bug or an enhancement or a fix that needs to be done, we will issue new decoder firmware. It can be loaded onto this device from your laptop with a serial by micro USB that's supplied with it. And then from there, you can take it out to the field and you can update decoder firmware. You can do other diagnostics, turning stations on, turning stations off. You can read voltage. You can check your milliamps. There's a lot of good stuff with the diagnostics, and you can see the station test. You can also do a click or flow sensor test. You can treat it as a volt or an amp meter where you can see your exact voltage on your line. And here's a few more things. You can program your decoders connected to the 2-wire path. Turn your stations on or off to check some diagnostics, check your decoder status, check your 2-wire path voltage. It comes with 6 different languages that you can change, but I'll caution you, if you get in there and you get curious and try to change it to Chinese, you better know how to get around because it's going to be fun trying to change it back to English. You can update the decoder firmware, and you can install decoders actually before programming. You can either do that from the clock or you can do it from this mechanism too. Some diagnostics. If you look at one of the screens is a decoder status screen. By hooking it on, you can go ahead and check and see exactly what's going on with it. You can see all your status at a glance. You can show your current draw. You can see if you look at the top, the decoder state. Be very aware of this. And typically it'll say normal when it's good, but it might say output shorted. It might say damaged. It can actually say a couple of different things, but always be looking at that. as for your one below where it says current, if it's just sitting there dormant, it's typically around 3 milliamps. You can look at your line voltage at the decoder. So on this one where it says 33.22 volts, that's right where it should be. It's right in the sweet spot. Typically, I tell people that it should be between 30 and 35 volts. And you can show this one right here is actually a 4-station decoder that it's hooked onto. You can see if it's got a solenoid attached, and you can see if it's turned on or not. And see the yes, yes, and no on number 4. Number 4 port is not being used. It's only 3 out of the 4, and none of them are turned on. Another handy feature is you can turn stations on from the ICDHP. So if you go to the turn stations on and off and you turn it on, then I would go to the status to view your solenoid activity. And typically, if you have a solenoid and it's turned on, you'll see the milliamp jump because now it's supposed to be drawing more power, and it'll typically jump, 40 milliamps, somewhere in that range. By this one going to 53, it's a little bit more, but it's nothing catastrophic. If it goes to 150 or stays down at 3, you probably either got a shorted output or the solenoid might be damaged itself. The remote will, when it's hooked on to the decoder itself, it'll only turn on that station. So be aware if there is a master valve, it will not turn that on at the same time. Sometimes that's good because you can see in the other picture, there's a sprinkler head right on it. So if there is a master valve, it would turn it on, but you wouldn't see any water coming on. So be aware, it only turns on to what it is going to be hooked on to. You can do some diagnostics with flow sensors. In that screen, you can do an output tester, you can do an output simulator. You can actually program sensor decoders. On this one, it is a 2-inch HFS FCT 200, and you can actually see your flow rate, and you can actually simulate it to check your clock to make sure everything is working right. And if something is turned on, you can look at your flow rate too, and you can see in the bottom right screen right there, that's exactly what he's looking at. You do have to tell it also where you're looking at it, either if you're testing the controller or testing the decoder. That's kind of key, so you know exactly what you're testing. Another function is on the ICDHP, if you hook your red and blue test leads to the 2-wire path, you can see your exact voltage. If you try to do it with the meter, sometimes you'll see it bouncing around. The ICDHP is actually synced, so you can actually see the exact voltage at any time. And that is definitely helpful because then you can see if you're low 2-3 volts, you might have a broken wire, or if it's too high, that could be damaging, and it might be something at the controller level itself. The input is protected against accidental high voltage contact, but still be careful when you're hooking into it, but it is a handy tool. You can also, as I said before, each one of these decoders has a firmware version on it, and they can be updated through the ICDHP. What it'll do is by putting it in there and going to the firmware screen, it'll look and see what version is on the decoder, and then it'll compare to the two what is on the decoder compared to what you have on your ICDHP. And then from there, if it needs to be updated, you can update it. It takes about 2.5 minutes per decoder. So start it up and there'll be a progress bar. And then once you're done, you don't have to remove it. You're good to go. We're going to look at a couple of type of problems now. You have a single station, you have multiple station problems, or you could have all stations. So let's take a look at the single station. For a single station, you have one station that's not working, go and check and confirm the programming at the controller itself. Make sure it is actually supposed to come on, and that the controller is actually seeing it. You can check the valve. Make sure the valve looks good. Check the wire connections from the on the decoder solenoid side. Make sure that it's at the decoder's the wire connections look solid. Also, if everything still looks good, check your voltage on the 2-wire path. It's right here, it says 20 to 40 volts, but the sweet spot is typically 30 to 35 volts. 20 is getting kind of low. Look for 30 to 35 volts, somewhere in that range. If everything looks good, your decoder is still not reading, put your test decoder on and then see if it will read that test decoder, and try to activate the station too. Check your solenoid resistance. Your solenoid that's on the valve currently should be between 10 and 40 ohms. When you read ohms on the solenoid, remove the power first. Don't read it with the power on. It's not a good thing, trust me. And if that looks damaged, you can always install your test solenoid and then see if your decoder pulls it in. And then activate station. Typically, that checklist right there will run through the majority of the problems that you're going to run into. Using your ICDHP, if you have one, you can check and confirm the programming that is on the decoder that the controller is supposed to be seeing. Make sure your station number is correct and everything is like it's supposed to be. Check the wire connections from the decoder to the solenoid again. Check the decoder to solenoid with the ICDHP. Like I said, you could turn it on and go back and check your milliamps. Make sure that it's jumping about where it should be. Check your voltage, check your amperage, and check your programming. You can install your test decoder if you cannot read it with your ICDHP. If you can read it, then you can check your voltage and a lot of other things, and make sure if you can't read your current decoder, but you can read your test decoder, more than likely it's damaged and it needs to be replaced. You can also activate the station as a check. If you turn it on and you don't hear your solenoid click or it doesn't turn it on, install your test solenoid and then see if that functions. If it functions, the solenoid on the current valve does not, more than likely you just have a bad solenoid. Activate the station with both of those things on. Now we're going to go into multiple stations. Check and confirm the programming of the controller. You can kind of see there is a pattern that is kind of emerging. Are your stations on the same wire path? Treat as a single station if on different wire paths. So if you have 60 zones out there and it's kind of all over the property, more than likely you're dealing with single problems. If they're all in the same series, like 5 or 6 of them in a row, more than likely you're looking at a problem that's right there, and that's what it's saying. Check your wire connections. If you have a last working decoder, first non-working decoder, make sure your connections are solid and with proper 3M DVR-Y6s. Check your voltage on the 2-wire path. It should be 20 to 40 volts. Typically, it's going to be 30 to 35. That is your sweet spot. If you are on your last working decoder and it looks good, it should be just about the same on your first non-working decoder. And that's where you check your voltage at the problem to make sure it's about the same. If you have a problem with all stations. Check your controller first. Controller is kind of like the heart. If your controller is not functioning properly and something is damaged inside the controller, more than likely none of your zones are working. So if all your stations are not working, check your controller first. Reset the controller. You can disconnect all the field wires and see if your controller comes back to life. You can, while it's disconnected, check it also with your test spare decoder and solenoid. As if it works with that and nothing's out in the field, you might have a damaged decoder out in the field that's pulling too many milliamps, and it could just be dragging it down and shutting your line voltage down. Reconnect your field wires one pair at a time. If your milliamps are high, and you can do that usually on a diagnostic screen, take a look at your milliamps one pair at a time, because that might show you exactly where your problem pair of wires are or the direction that it might be. Using the half method, if you know which pair it's on and you know where it's going and you see a high amp draw that's shutting the line down, you can go about halfway out, cut the line. If it comes back to life, then your problem is past that point, and keep having it until you hone in on the bad decoder or decoders. Another way, and we're going to get into this one too, is using a 24-volt supply. Remember, the controller is supplying DC volts. So when you use DC volts, you can't use the clamp on meter. It's reading in AC volts, and the decoder being DC, you're going to get faulty numbers. And you can use it to go down the line to locate where your issue is. All right, we're going to take a look. This is a typical 2-wire supply. This one's a little bit progressed a little bit more. What it is there's a 110 to 220 or 110 to 24 volt transformer inside, and it's got an on-off switch. Coming out where the 24 volt side is, you can see there is a red and blue that hook into your 2-wire path, and you can see it's not hooked into your controller. You do not want it hooked in there. At that point, you can go ahead and turn it on, and it will send 24 volts down the line. On your 2-wire path, from that point, you can use your X-Tech or your Armada Pro 93, Pro 95, your suitable clamp meter, and you can go down your paths. You can do single decoders, and you can also do the whole wire path, but you only want to do one wire at a time. You can see this one is only on one decoder, and it's doing about 9 milliamps, and that's about where it should be. You're going to see a little bit differentiating numbers in some of the slides in here, but typically between 7 and 10 is about where you need to be per decoder. X-Tech, it reads AC current, and it says 10 milliamps per decoder, so that's about right. A little bit more, a little bit less is not going to be catastrophic, but you can tell if it's way low or way high, you got something going on. Your milliamps reading should decrease as you move away from the controller if you're doing the 2-wire path, because you're dropping some out the further out you go. 40 milliamps per decoder when a decoder station is active, don't worry about that. That is actually a setting that's in the controller. When you turn it on, that's that 40 milliamp jump that you see. That really, that should have been taken out of this. That does not go on the screen. You can read both wires, the red and the blue, and see if they should be about the same. Typically they are, but if they're different, you might have a damage in the decoder also. Here's a typical 2-wire path leaving the controller, and you can see each decoder, if that 24 volt is hooked onto it is going to be about this one right here is about 7.75 milliamps per decoder. When you hook the 24 volt power supply, if you look at it, you have about 28 decoders, and 28 times 7.75 is about 217. Remember, it's disconnected from the controller. Halfway, using the halfway method, it's about 105. Okay, so using the 24 volt supply, connect the 24 volt supply to the wire path. Some controllers, our ACC1 does not have the feature, so you would have to supply an external transformer. I've actually got on my truck, a transformer out of an ACC controller, and that's what I use as mine. But on the ACC2, that feature is built in, and I will be showing you here in a minute where to find it on that. So you wouldn't even have to disconnect it to be able to put it in that 24 volt mode. Disconnect the controller first. That's the wires first. On the ACC2, you would not have to because of the feature I just mentioned. Connect the clamp on meter to any single wire to get a reading. Good decoders is going to draw typically 1 to 10 milliamps. I like to see between 7 and 10. That number is probably more accurate. Multi-station surge arresters and sensor decoders are being read also at the same time. So if you're on the wire path and you're back at the controller and you're on the main feed red or main feed blue, you're going to read every decoder that's down there. A single station, 2 station, 4 station, 6 station. So it's good to know how many decoders you're actually on that line while you're working your way down. And we'll kind of explain that in a couple of screens. Use like the half method when you're disconnect. Use the like half method. So that's a little bit of a mouthful there. So if you disconnect the wires in the middle, your milliamps ought to go up and down as you're dropping decoders in or out. And also you can check your current at any point on the wire path. Now remember, being in AC volts, so you have to have it in the proper setting. Now on the ACC2 controller, if you go to the decoder menu and then select decoder diagnostics, it takes you to the screen down below. At that point, if you look in the bottom right, it has wire test. If you activate the wire test mode, it will send it'll take it from DC and go to a 24 volt down the line without having to disconnect. So that's another great feature that is built into the ACC2 controller, or A2C. All right, decoder troubleshooting, basic concept. If you look, this is as you can see in the picture, that's an ACC1 and you have 10 decoders. If you take it offline, put your 24 volt supply on. If you have it could be 10 decoders, could be 20, it should be a percentage. Right now we have 10 decoders here, so every one of them, if you have 10 decoders times 7.75, that's 77.5. So you ought to be dropping 10% every time you move your way down the line. And there's a representative of it, but they're using a 10 milliamp, which is perfectly fine too. You ought to be dropping every time you move your way down the line. Now, if you're doing the single decoder, it should just be 10, 10, 10, 10, 10. But if you're on the 2-wire path, it ought to be 100, 90, 80, 70, 60. Now, if you have a high amp draw at the controller and you take it off and you put the path on, the transformer on, here's a typical numerical thing that you would see with a clamp meter. And sometimes it's even high enough to where it'll keep shutting it down. But if you look and you're at 2000, if you clamp or go to the next one, 1999 or 1990, 1980, and it's dropping down until you get about halfway, you go from 1950 down to 40 milliamps. So that pretty much tells you where it dropped. That decoder before is going to be your bad decoder. Replace it, get it out of there. And as long as there's no other bad decoders, it should fall back in line at your controller level. A damaged decoder, doing the same thing. You can have a damaged decoder and it not be extremely high milliamp, but you could still be high. So if you look, you've got 20 or 200, 190, 180, 170, and it drops down until you get from 150 and then 40. If you know you have 4 of them past that point, you're at 40, and you went from 150 to 40, there's your damaged decoder. So another one to replace. Damaged or broken 2-wire path. Typically, after a damaged, broken 2-wire path, you're going to lose everything past that point. And you'll see something that is representative of this. You're going to have number that drops incrementally until you get to a point where suddenly you get zeros. So your section between 2 decoders, where it went from a normal reading down to 0, you're going to have either your red or your blue or both wires has been damaged and need to be repaired. And that's where using your ground fault indicator comes in very handy. I'm going to do a quick brush on our new decoder technology. The new decoders, and I'm sure most people have heard about it, is our EZ decoder. Now, the EZ decoder is a little bit different animal. There is no DC volts. It's all straight 24 volts, 50 to 60 hertz. In the United States, it's typically 60 hertz. So you don't really need a special voltmeter. There's no special wire permitted. You can use existing wires as long as they're good. You can go up to 3,000 feet if you have the proper gauge wire. Now, being AC volts that this is running on, you have to follow AC volt wire laws. Typically, most systems are done with 14 gauge. 14 gauge is about 2,290 feet. So it really does depend on your wire gauge, how far you can go, and how many you're turning on at the same time. It requires no special wire connectors. As the other decoders systems that we produce, we supply 2 3M DBRY6s, and those are what we would like to have seen. They are the best. You will have a lot fewer problems when using those. But this one right here, the EZ decoder, you can use standard waterproof wire connectors. And another nice thing, where the other systems will require extra decoder grounding, this one does not. You don't need surge arresters and you don't need ground rods every so often. Just make sure at your controller, if there's a ground lug, something is going to be hooked into it as specified where it needs to be. But out in the field, you don't need extra. The EZ decoder system, that module plugs in, and when it plugs in, you're allowed to also have hybrid technology. You can have some conventional systems or conventional wires along with the EZ decoder. But when you have the EZ decoder in there, it will automatically recognize what slot it's in. And if you, like this one right here, has 3 other modules, so your first stations will be conventional, and your decoder will start after that. So it would be 25 on. You have 54 stations max in any combination. No special inline grounding. It's cost effective. So you can bring 2-wire into a lot of projects. And this is more catered to smaller projects where you're not going to be going far distance. Your typical break-even count is going to be about 12 to 15 zones. All right, going back to the decoders. Here's your controller. And let's say you take your 24-volt power supply. With all those decoders, if you multiply those by a normal number, 7 3/4, you're going to have about 217. Now, this is going to be a typical system without problems right here. On the one that's all the way out, it's 7.75 because you're only reading one decoder. On that leg right there, the number of decoders right there times 7.75, and you get 47 milliamps. On the leg to the left that branches off, 54. That 47 will include 10, 11, 12, 13, 14, and 15. The 194 will be 4 through 15 and 23 through 28. So you can kind of get a feel for where your milliamps should be by knowing how many decoders are present or should be present. Now, if you hook up your 24-volt power supply and suddenly you get a high number, 2318 in this instance, you can go out there and start either breaking it and see if it goes down to a normal number, or you can use your clamp on meter and start looking. So at that point, between 9 and 10, if you have 47 going out, okay, well, that one's fine. That's not a problem. If you look at that number, you have 2,224 milliamps. Okay, so your problem is going to be after that point. At that one on that branch, it's 39. No, you're fine. There's still not a problem at that point. If you look at that number, it's 2,216. So your number is probably going to be between 16 and 18. And then you check 17 out and it's 2199. So you pretty much, by process of elimination, you zeroed in on where your problem is at. Take it out, replace it, and you should be back up and running. Some other ACC or ACC2 or even some of our other systems, the decoder troubleshooting, one thing that's very handy is to have a site-built drawing. Otherwise, you could be walking around a property not knowing exactly where everything is at or what's before it, what's after it. You can really chase your tail. Knowing your decoder's location and quantity is a great time saver. Know your 2-wire routed locations. For the examples we just looked at, it's a lot easier to look at, okay, high, 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 low, 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 seeing exactly where you're going. Single station decoders or multiple station decoders are hopefully on that site-built drawing too. And some other decoder troubleshooting techniques. Confirm your voltage at the controller. Make sure it's the same as what's out in the field. Have your spare good product before you show up. Make sure you've got extra decoders, extra solenoids, because more likely you've been called out there for a problem. Make sure you have what you need. Otherwise, you're going to be going back and forth getting product that could have saved you a lot of time by having it. And as we touched on first, your test equipment, make sure you have the right equipment, and also, take it out and get familiar with it. A lot of the equipment that I've had for, between 10 and 20 years. So I know exactly what it's going to do. I know exactly what I should be getting as a reading. And be familiar with your product, your ACC, your A2C, your I-Core, your Easy Decoder. Know how each one of them is laid out and how each one of them is supposed to respond. At that point, hopefully you've learned something on this. Reid, I'm going to bring you back in too to see if we had any questions, and we'll kind of do a quick wrap up and go from there.
Yep. So we didn't have any questions, or we did have a couple of questions, but I addressed them as we went along. So I think we're good. Really appreciate everybody joining us. So all three of these webinars will now be on YouTube. So we have a Hunter Southeast YouTube account that these 3 videos will be on, along with a few other webinars that we've done in the last 6 or 8 weeks or so. So be sure to check those out. And really taking everybody to taking the time to spend with us. We just gotten a couple questions coming in here. Mike's asking if we could do a full training like this on the EZ system, and yeah, that's definitely something that's on the list to do, is do a quick training. Thing about the EZ system is, like it says, it's easy, so it'll be a quick one, but definitely think we could probably bring Dirk back in and do that. So yeah, so if there's no further questions, hope everybody enjoyed it, and get in contact with us if you have any questions. We'll be happy to help you out. Thanks again.
Thank you very much, and hope to see you guys soon. Stay safe.